This is our lecture number 5. Today we are going to see that is vibration of air column in a pipe. Vibration of air column of air column. In this we will see two articles at a time. Here first, vibration of air column in a pipe. Vibration of air column in a pipe open at one end and closed at other end. And second article, vibration of air column in a pipe open at both ends. Here see, we will see these two articles at a time because we have to compare the different equations. We have to make the comparison in the two. So we will see here at a time. See here, vibration of air column in a pipe open at one end and closed at other end. Suppose we consider three different diagrams. Here, suppose this is a pipe open at one end. We will see same thing here, same length of pipe, and here we consider the third one. Length is same. Suppose small l, this is the length of the pipe. Suppose you consider this diagram A, B, C. Now we will see different modes of vibrations. Here in this pipe we consider, suppose when air column vibrates, suppose we get here that is a one antinode and one node. Here we consider two antinodes like this. Two antinodes. This is one antinode, and two nodes. And here we consider three antinodes and three nodes like this. See here, antinode, 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 and here nodes. That means always at open end antinode is formed and at closed end node is formed. So we have seen here, that is here one antinode at open end, one node at closed end, and we increase its number by 1. Here we get 2 antinodes, 2 nodes, 3 antinodes, 3 nodes. Now here you see, suppose we consider here n be the frequency and lambda be the wavelength, n1 be the frequency, lambda 1 be the wavelength, n2 be the frequency, lambda 2 be the wavelength. Now here you see this L is the length of the pipe. Now we can write here, we compare this wavelength and length. See here, lambda is wavelength, therefore L is the length of the pipe. The relation between these we get here, that is a half loop. Half loop means one antinode and one node, and length of the half loop is always quarter of the wavelength. Therefore I will write here, that is L is equal to lambda by 4, or lambda is equal to 4L. Now here suppose you know this relation, velocity v is equal to n lambda, and therefore we can write here n is equal to v upon lambda, or n is equal to v as it is, and value of lambda is 4L, and this is the fundamental frequency. And if we consider, we correct this by adding end correction, then we get here n is equal to v upon 4 into L plus E. This is the, by using end correction, suppose you consider this is equation number 1, or we consider this also equation number 2. These equations 1 and 2, here we get with end correction fundamental frequency, and this frequency we call it as a fundamental frequency. This is the lowest possible frequency in case of air column, when air column, or we consider pipe open at one end. Now we write the similar relations here. See here, suppose we get here relation between L is the length, every time we take L be the length of the pipe, same length of the pipe. Now here you see L is equal to, here you see that is a half loop and this one loop. Now we write here 3 lambda 1 by 4, because lambda 1 by 4 is the length of a half loop. Here there are 3 half loops, therefore L equal to 3 lambda 1 by 4, and therefore lambda 1 is equal to 4L upon 3. And again you know V is equal to N1 lambda 1, and therefore N1 is equal to V upon lambda 1, or N1 is equal to V lambda 1, value of lambda 1 4L and 3 here, or we get here N1 is equal to 3N, or N1 is equal to, we write here 3 into V upon 4 L plus E, or we get here N1 equal to 3N, and this is the higher harmonic or first overtone we call it as a. Now for third figure we write here L equal to, see here 5 half loops are there, 1, 2, 3, 4 and 5, and length of one half loop is quarter of the wavelength. At that place we get here 5 lambda 2 by 4, and therefore lambda 2 is equal to 4L divided by 5. Again you know V is equal to N2 lambda 2, and therefore N2 is equal to V upon lambda 2, or N2 is equal to V as it is, and value of lambda 2 is 4L and 5 here, or N2 is equal to 5N, and if we use the end correction then N2 is equal to 5 as it is V upon 5 upon 4L, that means 4L plus E. That means here we write N equal to 1N like that, N1 equal to 3N, N2 equal to 5N. That means if we compare all these relations, then first harmonic, here third harmonic, fifth harmonic, that means we can say general statement that only odd harmonics are present here, are present. Only odd harmonics are present, that means 1N, 3N, 5N. This is fundamental frequency. This is first order means third harmonic, second order means fifth harmonic, like that. Now we will see that is for pipe, vibration of air column in a pipe open at both ends. Suppose you consider this is the pipe whose length is L, same length we consider at every place. Okay, this is the length of the pipe. Now here we consider, suppose This is diagram A, B, C. Here we can say n with the wave frequency, lambda with the wavelength, n1 the frequency, lambda 1 with the wavelength, n2 with the frequency, lambda 2 with the wavelength. Now we consider here that is nodes and antinodes. Here always at open end antinode is formed, therefore I will show like this. That means this loop like this. Here we get antinode, node, antinode. Now see here. We will increase one by one. See here, antinode, 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 and two nodes. Now like this, antinode, 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 and three nodes. That means here two antinodes, one node, and we increase its number 1, 1, 1. That means each time we increase 1 by 1. 2, here 3, 4. One node, two nodes, three nodes, like that. Now we will see here. Suppose we consider here, we compare wavelength and length, then we get here L is equal to. See here, this half loop and this half loop means total one loop. Therefore, I will write here, length of one loop is always half of the wavelength, therefore L equal to lambda by 2. Therefore, lambda is equal to, we write 2L. V is equal to N lambda, you know, and N is equal to V upon lambda, and therefore N is equal to V upon 2L. Or we consider here, this is the fundamental frequency in this case. I will write 1, 2. Here also 1, 2. Now, therefore, I can write here N is equal to V upon 2 into L plus, I will write here 2E, because end correction is double, here 1 and here 1. Here suppose here is E and here is therefore 2E. Or I write here N is equal to 1N, and this frequency we call it as a fundamental frequency when pipe is open at both ends. Now we will write for other cases. Here you see, L is the length of the pipe. Then here this half, one loop, and this one means two loops, and length of two loop is always equal to wavelength. Therefore L equal to lambda 1, or lambda 1 equal to L. V is equal to N1 lambda 1. Therefore N1 is equal to V upon lambda 1. N1 is equal to V upon L, or N1 is equal to 2 into V upon 2L, or N1 is equal to twice N, or N1 is equal to V upon L plus 2E. Suppose this is equation 2. Here again we consider 1, 2, like that. Now for third case, you see L equal to, see 1, 2, 3, 4, 5, 6 loops. That means I can write here, that is 6 loops. 6 half loops means 3 loops, 3 lambda 2 by 2. Lambda 2 equal to twice L upon 3. V is equal to N2 lambda 2. Therefore N2 is equal to V upon lambda 2. N2 is equal to V upon twice L, and here 3, or N2 is equal to 3N, or N2 is equal to 3 V upon 2L plus 2E. Okay, this 2E, and we consider suppose this equation 1, this is equation 2. Now see here, N equal to 1N, N1 equal to 2N, N2 equal to 3N, like that. Here we can say general statement that all harmonics are present here. All harmonics are present. That means when your pipe is open at one end, that means closed at other end, then only odd harmonics are present. But whenever pipe is open at both ends, then all harmonics are present. And fundamental frequency, here N equal to V upon 4L, and here N equal to V upon 2L. That means if we consider a pipe, suppose this is a pipe, we consider this is pipe small pipe, one end is open, then here fundamental frequency is L equal to V upon 4L, and if we cut this, suppose we cut this, that means we consider same length, and if we consider second end also we have open, we made open, then fundamental frequency becomes V upon 2L. That means fundamental frequency here doubles. V upon 4L, it becomes V upon 2L. And main difference between these two, that is, in case of pipe open at one end and closed at other end, only odd harmonics are present. But here, when pipe is open at both ends, then we consider here, that is, all harmonics are present. This is all about, that is, vibration of air column when pipe is open at one end and closed at other end, and vibration of air column when pipe is open at both ends. I hope you all understand this. Now we consider next article. That is practical determination of end correction. Practical determination of end correction. Practical determination of end correction. See here, we consider when pipe open at both ends, then we can write here, that is V equal to, we can write here, that is, if we consider different frequencies and different lengths, then we can write here V equal to, that is, N1 L1 is equal to N2 L2. That means we consider N1 L1 equal to N2 L2, N1 be the frequency, N2 be the second frequency, L1 be the first length, and L2 be the second length. Then here we get, right, N1 as it is, and value of L1 means we write L1 plus twice E, which is equal to N2 as it is, L2 plus twice E, second length. And if we solve this, okay, I will solve here. N1 L1 plus N1 into 2E is equal to N2 L2 plus N2 into 2E. Or we consider here N1 twice N1 E, and to this side minus twice N2 E is equal to N2 L2 minus N1 L1. Or we consider here E to be common, then 2 twice E to be common, N1 minus N2 is equal to N2 L2 minus N1 L1. Or we can write here, that is E, that is end correction, equal to N2 L2 minus N1 L1 upon 2 into N1 minus N2. And by using this relation, we can easily obtain the end correction when pipe is open at both ends. Now we consider the next one. That is same thing for a pipe closed at one end. Here we consider pipe open at both ends. Pipe open at both ends. Now we consider here pipe open at one end. Now here we consider same thing, V equal to N1 L1 is equal to N2 L2. Or we write simply N1 L1 is equal to N2 L2. N1 as it is, small L1 plus E is equal to N2 as it is, small L2 plus E. N1 L1 plus N1 E is equal to N2 L2 plus N2 E. Now this side, N1 E as it is minus N2 E is equal to N2 L2 and this to this side N1 L1. E to be common, N1 minus N2 is equal to N2 L2 minus N1 L1, and therefore E is equal to, we get here N2 L2 minus N1 L1 upon N1 minus N2. Suppose this is equation number 1. That means when pipe is open at one end, closed at other end, we can eliminate this end correction. When pipe is open at both ends, we can obtain the value of end correction here. By using all these, we can easily obtain the end correction in both cases. This is all about vibration of air column. I hope you all understand this. Thank you.